In this video we're going to look at how to use multiple derivative rules to find the derivative of functions. Here in this first function we have f of x is equal to 3x plus 1 times x squared plus 7 all divided by 5x squared plus x. And here we have the quotient rule, but then when we take the derivative of the numerator we're going to need to use the product rule. So we're going to use the combination of the quotient rule and the product rule. And in this case, we're going to start with the quotient rule. So here, f prime of x is equal to g of x. So we rewrite g of x times f prime of x. And remember, we said that this is the product rule. So we're going to have the first term times the derivative of the second, which is 2x, plus the derivative of the first term, which is going to be 3, times the rewrite of the second term, x squared plus 7. So everything in these brackets is the derivative of the numerator. And then we need to get back on track with the quotient rule. So now we're minus f of x, which is the rewrite of the numerator, 3x plus 1, times x squared plus 7, and now times g prime of x. So we're going to take the derivative of the denominator. So and that's going to be 10x plus 1. All divided by the denominator squared. So we have 5x squared plus x all squared. And that's how we start with the quotient rule and we incorporate the product rule in. This next problem is again the quotient rule and the product rule, but this time we're going to start with the product rule. And then when we take the derivative of our first term here, we're going to use the quotient rule. So we have f of x is equal to ln of x divided by 4x squared times x squared plus 7. So f prime of x is equal to the first term, so we rewrite the first term, times the derivative of the second term, which is 2x, plus the derivative of the first term, which is our quotient rule. So we have 4x squared, g of x, times the derivative of f of x, which is 1 over x, the derivative of ln of x, minus the first term times the derivative of g of x. So that's 8x. All divided by the denominator squared, 4x squared all squared. And then times the second term, x squared plus 7. So here, everything that I'm about to bracket, this was all the derivative of our first part of our function. And that turned into the quotient rule. Now let's take a look at a couple of examples that require the use of the chain rule. So here, we're going to start with the quotient rule, and then when we take the derivative of the numerator, we're going to use the chain rule. So here, f prime of x is equal to the denominator rewrite, so 2x squared plus 1, times the derivative of the numerator, which we need to use the chain rule. So we're going to multiply the 3 down out front, so we end up with a 3, times everything in the parentheses, 3x plus 1, subtract 1 from the exponent, and then we need to remember to take the derivative of the inside, which is 3e to the 3x, minus the numerator, so e to the 3x plus 1 to the third, times the derivative of the denominator, which is 4x, all divided by the denominator squared, 2x squared plus 1 all squared. And that was the combination of the quotient rule and the chain rule. And now I want to look at one more example, and it's the product rule and the chain rule. So here we have f prime of x is equal to the first term, x cubed plus 3x squared, times the derivative of the second term, which is 4x cubed plus 4, plus the derivative of the first term, which is the chain rule, 2 times x cubed plus 3x, times the derivative of the inside, which is 3x squared plus 3, times our second term, which is x to the fourth plus 4x. And that's how we use multiple derivative rules